so it's exactly what it sounds like. You're basically, you're taking a part and you're putting it in a bag in order to apply pressure. And so this is no different than a lot of other ways that you would assemble anything, in that basically what you're doing is you're clamping stuff. In this case, you're using atmospheric pressure to clamp it. So if you think about it, if you have a bag, you can even think of it like a Ziploc bag. If you take a bag, open it up, drop something in, and close it up, there's going to be some air inside the bag, some air outside the bag. The air pressure inside the bag is going to be the same as outside. And so at sea level on the Earth, that's 100 kilopascals, which is 1 atmosphere, which is about 15 psi. So if you remove all of the air on the inside, and that means you have about 15 psi of clamping pressure on the outside. And that's actually quite a lot. And so the same, basically the purpose sold for vacuum bagging, it's not necessary to use exactly these materials at all. And so almost any plastic sheeting that's compatible with the resin that you're using, so this is something easy to test, will work. A lot of plastic sheeting that has the same tactile quality that you're going to see out there is polyethylene, and that will work just fine. And so the difference with the more expensive commercial stuff is that this stuff is, and you let it bunch up in crease, but that won't show up on your part because of all the extra layers. And so the bag itself, I'm going to seal with this silicone mastic tape. This is really convenient because it's so thick and squishy. You can sort of massage wrinkles into it, and it will still seal on it. Again, if you have not a lot of time, it's really good to use this, but it's really expensive. So compared to just packing tape. And so, of course, with just packing tape, you have to be very careful that you seal it without any gaps. So, to flow out of the part. And so the issue that this addresses is that when you take a vacuum line and you put it onto a plastic bag, it's very easy for the bag to actually seal on itself in a small area around where you put the vacuum port in. Because again, you'll have 15 psi pushing together around the vacuum port. And so what including this felt material will do for you is it will keep that sealing from happening and allow the air to flow out from everywhere around the part. So you really want this breather material to envelop the entire part, and the vacuum port needs to go to some corner of the breather material. This is just a cotton duck fabric, just an untreated cotton duck for the layup itself. And so the next layers are sort of, some people will use both, and some people will use only one. And the results that you will get from either will be comparable. So what one of these is it's called a release fabric. And so this is a woven fabric. It doesn't feel like anything special, but it's made out of similar materials as the vacuum bag. They're often made out of polyethylene, which tends not to stick to epoxy very well. Cups are made out of. You'll notice that a lot of the resins will drop out of the cups very easily once they're cured. And one of the really nice things about using this kind of fabric is that it leaves behind the surface texture of the weave, which makes it relatively easy to glue things to the part once you finish the part. And the other thing is some people like the surface finish that you get because it will look like a matte surface finish when you use this. Again, totally unnecessary.
You can use a shower. I tried this with a shower curtain.
Yeah.
It's almost the same.
Yeah, so long as it's porous. Yeah, if you can put your mouth up to it and blow through it, it's fine. And so, for that exact reason, this serves very much the same function. People will call this peel ply, or some people will even call it breather or breather film. All this is basically more of this with holes in it.
Smart together.
So they're all about 1 centimeter apart. Obviously, for a small project, you could make this yourself with a pin. Resin is glue, which means if your performance has anything to do with weight, you want as little resin as possible, as long as you're gluing everything together. And the other thing is that since this material is so much stronger, the fibers, you want it to be what's called as consolidated as possible. So you don't want extra resin separated.
Smooth cast.
And so when you put that all together and you put X amount of resin in with your fibers, and then you pull a vacuum, you're going to pull excess resin out of the fibers. And the question then is, how much do you want to pull out? If you need to make something watertight with very few plies, you actually want to leave some excess resin in there. Otherwise, you're going to have to go back and seal it. In that, you're going to spend the same amount of time.
What about reusable polyurethane bags?
You mean like you're making your own bag?
Yeah, I mean there's kits that you can buy and I think you can just source your own, it's like thicker polyurethane.
Yeah, if you get the commercial bagging material, like the stuff I'm using now, the bagging material is quite reusable. Of course, everything else is going to get infused with resin. So it's not.
But if you get use the mastic, can you then open it again and close it again?
You often find yourselves in a situation where you accidentally braided the mastic. The bag tends to be really flexible. These blades. Okay. So we have a thing. And so what we're doing now, we're actually just going to cover these things in the cotton fiber and the resin, and then vacuum bag it, which is going to compress it all together. What we're doing essentially is we're going to encapsulate the foam as a core, and that's a very common way that fiber composites are used. Because you're going to end up with something, when you're using this resin, basically has similar material properties to lignin, which is basically wood is lignin and cellulose. Cellulose is the fibers, we have some cellulose. And so what we are going to make, by making a composite out of our cellulose and polymer that happens to have material properties very close to wood, is we're going to make, or very close to lignin, is we're going to make a composite which has properties very close to wood. And it even will look something like wood. It's kind of a nice thing. So you don't always have to encapsulate something. so at this point, you have to sort of decide how it is that you'd like to encapsulate or basically lay the material down onto it. And so this is called the layup. As you search online, you'll find often people will call the method of laying up the plies, they will refer to it as the layup schedule. And something that's pretty interesting to play with. For those of you who are building things like, you want to build like quadcopters or airplanes or stuff like that, is that the direction of the weave will matter a lot when you're doing something where you want to use a minimal amount of material for a given strength or stiffness requirement. And so we'll do that with two sheets.
It's almost and one sheet on the other side.
I remember what I was talking about. If your performance requirements and your geometry are both kind of crazy, then using glass or using carbon, you can get away with it with Kevlar as well. If you use those fabrics, the fibers are so slippery that it's very before I mix the resin, I'm preparing it as much as possible. You know, the sooner I get the resin down, the sooner I get the vacuum down on the bag.
It's a similar technique if you were laminating thin sheets of wood.
Exactly the same. The only difference is one-sided bag. And that would help things stay flat. Okay. Now we just need to connect a vacuum supply. No vacuum supply is ever going to give you 100% of atmospheric pressure. All of the air. You're in really good shape if you get negative 12 to 13 psi. It's even that is not necessary for most projects. So a lot of this stuff you can actually get away with just using a vacuum cleaner. But if you need more pressure, the next solution is one of these, which is just a vacuum pump. Anyone who sells this stuff, the vacuum bag supplies, such as boat companies, small aircraft companies, will sell these as well. And these cost a few $100s, up to about $500. And for single shop projects like this, they work great. The other, and so these are sort of brilliant devices which you just connect them to shop air and they exhaust more air than you put in. And so they have a vacuum side which you connect to your bag. And you just leave that on. These consume a lot of air. So
can you repeat what it is called? What it's a vacuum generator?
a vacuum generator. Yeah.
So once you extract the air, then you turn the nozzle off, or does that continue to process there too then?
So It's a good question. The answer to that question depends on how leaky your bag is. If you have a perfect bag, you can shut it off. It is very common for people not to shut it off until it's clear, just to make up for any leaks that are. I know.
You don't really want that thing running. I mean, better up on that.
We actually run these.
Yeah.
Just because we find that we go through more. So we teach a lot of classes, and we find that we go through more vacuum pumps quicker than we go through these. And so it's like it's harder to destroy these. It's very easy to.
So you would recommend this one?
Only if you already have the shock air.
Yeah.
But if you do, I do
But
recommend
like
it
we
just
have
because-
like a big pump, like a shopper.
Big pump.
If it's about this big,
Yeah.
you'll be able to run one of those pumps.
Yeah.
Yeah, I mean, the trade-off is this is 50 and that's...
And the other thing, which is a nice thing to set up, is actually a vacuum pot.
Vacuum what?
A vacuum pot. And so you can use a compressed air cylinder, a large one, but if you pull a vacuum on that and then put a valve on that, you'll have a really nice if you're using like a vacuum cleaner, a garden hose is fine for the amount of pressure that you want to pull. If you're using one of these pumps, and even the Venturi vacuum generators, you're going to want to use a pretty stiff tube to your vacuum, because otherwise the tube will just collapse from the air. Sometimes they can even seal. But it'll at least slow things down. The bag to be able to move around a lot. And so for that reason, it's a good idea to add tucks to the bag. So obviously, since I have a symmetrical bag, and I'm doing this on one side, I'm going to have to do it on the other top side as well. So that's just producing extra material that can move around and fill the space. Three-dimensional flights. So if you ask the companies that make this vacuum bagging material, they say you should use twice as much bag as you think you should.
So you don't put the raisins until the vacuum bag is ready?
That's correct.
Yeah.
So I'll sort out the top side of the vacuum bag. I'll be racing to it and curing. But it's a fine strategy to close up three sides of it, and then move your material into it. So I'm going to wet it all out, reducing the amount that I'm going to do. Wet it all out just on top of the bag. So So it's not actually going to take very much resin, which is good because we don't have very much. When you're doing this, be careful about what type of cups you use. PLA cups will be dissolved oftentimes by part A of these. One of the smooth-on resins, this one's a hard plastic urethane. This is actually the same bottle that made those two. It's urethane. And so holding a stirring rod next to the bottle, it matters more when the bottle's more full. You can't tip it over much. But that helps the resin run down the stirring rod instead of the side of the bottle, which will be soon too. So as you can see, it's entirely possible to pour resin from the bottles without dripping a single drop. Because of how thin it is. But some of the thicker ones, if you mix a whole cup, it's actually a lot of work to get it mixed properly. And you're better off sort of spreading it out over the cups. So I'm going to go ahead and mix these two together.
What about VOCs? I mean, are any of them need to be done at fume hood?
So the vast had bad allergic reactions, non-contact reactions, just to the fumes of some of the nastier ones. The smooth-on crystal clear is a good example of one. It takes people down. And once you have a reaction, it's going to be several days before you can go back to being around those resins. Be safe about it. So that's probably more than enough.
Okay, you don't need to wet all the cloth.
Humidity play a big factor?
With some resins, with the urethane resins, what it will do is it will make it foam a little bit. For the purpose of composites, that's not a big issue because you're actually trying to push a lot of the air out anyway. So it's kind of okay. When you're making, that's part of the reason why the pink R2D2 is so foamy is probably
Abu.
polyester will, if you're working with that, you'll get your neighbors to call the fire department. Just from the smell. Yeah. That's not hyperbole. I know the taste of exactly what
You wouldn't be able to use a foam pattern with polyester either.
Gloves. It's important to get them off without pushing the resin.
Might be leaks.
Can't stress enough the value of doing things in smaller batches. With epoxy, for instance, you will have no trouble finding information about people whose garages have burned down because they mixed up a 5-gallon pot of epoxy, not realizing that it will actually ignite itself. Even like to protect in terms of putting a finish coat that keeps it from yellowing. I'm trying to think.
Degrade the properties when it's exposed, when it's yellow, it does that change the property.
They tend to get more brittle.
It doesn't fully cure for like 20 hours.
20 hours? Then they cut it out or just like this?
Yeah, leave it.
Alright.
Kind of like,
Did you do any Lister Academy?
See the other one?
No, we did not understand the process.
It's pretty simple, and I've seen it done. I've not done it, but I bag other stuff. For woodworkers do this.